In 1997, a tragic flood hit here in the foothills of the Colorado Rockies, and no one saw it coming. But one man had the idea to enlist citizen scientists in what's become an army of weather watchers to help reduce the risks of this ever happening again.
Where we're seated here today is very close to where a very, very, very heavy localized storm occurred back in 1997. Up to 14 inches of rain is what was about to make a major disaster.
Spring Creek, normally a placid stream, became a raging, deadly torrent.
People here weren't aware of this huge surge of water that was about to arrive. Within a matter of minutes, a culvert unplugged, water rushed through underneath, water flowed over the top of the railroad, swept a train, a few cars off.
It just right to our doorstep. No warning, no nothing.
I was asleep, I woke up and everything was floating away.
Neighbors living close by were astonished.
It was only about a half a mile away that the 5 people who perished in that flood were living. We got very little rain.
We didn't really have much indication that there was lethal flooding going on very close to our house.
It was something that was just unbelievably startling to know that people were dying just right down the hill from all this water.
The 1997 flood and the extreme variability of local weather also shocked professional meteorologists like Nolan Doesken. He'd assumed NOAA's newly developed weather radar would provide sufficient warnings, so he'd chosen not to sound an alarm.
There was this great sense that technology was going to answer all of our challenges when it came to flood prediction, flood warning, seeing the helicopters the next morning hovering over, the sound that always tells you you've had a disaster, and knowing that I could have done something, and that has stuck with me.
It's like still drizzling, actually.
What Nolan and colleagues started is now called CoCoRaHS, the Community Collaborative Rain, Hail, and Snow Network.
How much?
Looks like about 100.
Today, citizen scientists all across North America make daily measurements of precipitation, just like the Doesken family.
We've been doing this for, 17 years now, and it's become such a regular part of our routine. No burden of having to do this.
Zeros matter, traces matter.
CoCoRaHS includes more than 20,000 volunteers, extending north to Canada's snowy maritime provinces and down south through sometimes dry regions like Texas.
I'm actually a 7th generation rancher, come from a long line of ranchers. Been around ranches from the time I was knee-high to a grasshopper till now.
Close to Midland, West Texas, Skylar Flake has been a CoCoRaHS observer for 6 years.
After we get done, feeding horses and checking on stuff, around here that needs to be tended to in the morning, walk out here every morning and check this rain gauge, see if we were lucky enough to receive any, precipitation throughout the night. A lot of zeros here, but we did have 3 good days of rain back in the, the middle of March.
To ensure uniform measurements, each observer pays $30 for a standard rain gauge.
Without rain, we're out of business. Our livelihood is directly affected by how much rain the good Lord blesses us with. It's pretty easy to have one rainstorm dump an inch on one end of this ranch and not get anything on the far west end of this, just because of how the rainfall came. If there's more of these CoCoRaHS gauges around, it's easier to see the weather pattern instead of one National Weather Service station that just collects the rainfall that falls at that station.
Too little rain or too much rain? Both are problems when you can't see what's coming.
Well, on the night of July 28th of 1997, there was only one rain gauge in the middle of town and a couple on the edge of town. None of them were reporting real-time weather conditions. Our goal was to make sure that if another storm like that happened, that we would have an immediate sense of where the rain was falling and a way of communicating that information quickly and efficiently.
In addition to regular daily precipitation reports, CoCoRaHS observers are also trained to monitor extreme weather conditions while they're occurring. In real time, their reports reach the National Weather Service so that NOAA can issue timely flood warnings. One of the first forecasters to see the value of this new source of data was Chad Gimmestad.
We're constantly evaluating, do I need to issue a warning for this storm or not? Right. If we think the storm's going to become severe, we want to get a warning out as quickly as possible.
While CoCoRaHS started with measuring rainfall, the H in its name stands for hail. Observers make standardized hail pads, styrofoam covered with foil, to record the number and size of hailstones, from grains of rice up to golf balls and even bigger. They're encouraged to report large hail right away. Forecasters now pay special attention to these reports of significant weather, since large hail is an indicator of tornadoes and strong storms, which also show up on radar.
The radar is telling me there's this much energy return from the radar, but that's not the same as having the human with the eyeballs and the ruler, because that human knows exactly what I want to know. The same radar picture could be half-inch diameter hail, or it could be 1.5-inch diameter hail. And now, now an alarm goes off. So I click on this alarm, and I see the report right here. It says Morgan County, Colorado, Fort Morgan. It gives me the latitude and longitude. Tells me his largest hail is 1.25 inches in diameter. My criteria for issuing a warning is 1 inch, so that means I need to have a warning out. And in just a few clicks of the button, I can draw this box on the map where I want the warning to be. And I'll quickly click the hazard, so I can say like 60-mile-an-hour winds, and here's the 1.25-inch diameter hail. Hit create text, and I get a window that pops up with text of the warning right here. And as soon as I press that button, it goes out to the news media, to NOAA Weather Radio. If it's a flash flood warning, it'll interrupt the programming on most commercial radio stations and cable TV outlets in the warning area.
So in effect, one person can make an observation, and within just a couple minutes, that can result in a banner across the bottom of a television screen with a warning?
Absolutely. The whole point of that is that person is helping out their neighbors by sharing that information.
Right. CoCoRaHS started with rainfall and a focus on Colorado. But then observers suggested more.
Once we started with rain, people said, if we can measure rain, we can measure snow. And I knew enough about snow to say that's a lot harder.
In Canada's maritime province of New Brunswick, observers Dan Matthews and Leslie Grattan have documented snowfall during a long, hard winter.
It's certainly not been a typical winter here. Christmas, it was plus 12 degrees.
Raining.
And raining. And by New Year's Day, we had 12 centimeters of ice on the pond, and we're able to have our polar dip.
Then the snow started.
Without Leslie, I'd have a hard job keeping the measurements going. She's got lots of stamina, loves using the snowblower.
You usually wait until after the snow stops before you start digging, because he who shovels early shovels twice.
The process is a 365-day-a-year program, and you trudge out in the morning, and then you're all bundled up because it's minus 20. Then I do my snow calculations, read the readings off the snow posts, get the snow depth. That stake over there is 48 inches tall, and there's 3 inches sticking out of the ground.
Snow is a more complicated beast. It varies in its water content, its density. It's blown around by wind. And we have had volunteers diligently digging through deep layers of old icy snow or fresh snow to identify not only how deep is it, but how much water is in that snow. There's a big difference between 2 feet of fluff and 2 feet of aged ice.
I dig down, and the bottom 10 inches of the snow is big snow crystal, snow grains. Well, to the scientists, that means something. That means that the system of thaw is starting to develop. You know, all this information is important, and it's not reported by a machine. When you get your sample in your tube, you take it in, and you put it on the scale, and you weigh it, and you're done.
Just as with hail and rain, increasing the number of data points dramatically improves the quality of forecasts.
You won't make the world news, but that sort of thing enhances the weather reports. You look at the map and there's thousands of dots all over, and you're a part of it. You're making a contribution.
All of those dots are individuals submitting daily data, filling in gaps through which extreme weather events might otherwise flow unnoticed, until it's too late. Add to those citizen science observations big data from satellites and supercomputers, and you've got a powerful early warning system. In 2013, another dangerous storm hit the foothills. This time, extreme rainfall impacted communities all along the Front Range, including Boulder, where NOAA's forecast offices are situated. Floodwaters were out of control. Half a year's rain fell in just a couple of hours.
In the 2013 flood, we had a lot of reports from CoCoRaHS observers here around Boulder, and so we were able to ramp up what we were doing quickly.
We had close to 1,300 volunteers submitting rainfall reports. We were able to have a map day by day as that storm was progressing.
We worked with the emergency managers to help them understand how serious it was. That got them moving faster. Using the radar data and the CoCoRaHS data, we were able to help them pinpoint, here's where it's the worst, and they can go evacuate those areas first. And in those cases, sometimes a few minutes does matter.
Time is really critical, and what you're doing is you're giving time.
Any observation from any of our observers could in fact be the observation of the big storm. And maybe those of us who suffered back in 1997 from a flood that we were ill prepared for, maybe we really are making a difference, and that's the biggest satisfaction for me.